Well, hello, Team C++. Today we're going to start a new video about C++ in general, computer systems in general, programming in general. I'm going to go through what is a computer, what is a program, what is a software, all these basics, computer programming languages, all these basics that if you are new to programming in general, you might want to stick around and watch this part of the video. If this is new to you, you know what, just watch it anyway. Um, uh, as I said, this video is going to be an introduction about computer system, computer programming, C++ in general. And the first part I'm going to start with is basically a very short show or PowerPoint presentation about what are computers and what are computers programming in general. So the first question I would like to ask here is, what is a computer? If I ask you to define a computer in one word, how do you describe a computer? Well, a computer is just a machine. So that's basically a one-word definition of a computer. So a computer is a machine. Now the question is, why do we need machines? Well, ask yourself the same question about your car. Why do you need your car? Well, machines in general, they can make our life easier. Let's take the car, for example. What can you do with a car, which is a machine also? A car can move you from point A to point B, and you can move by your legs if you run or walk from point A to point B. So what's the difference between the car and you walking the distance? Well, of course, it's going to be a lot easier, faster when it comes to riding a car to get to places. So as you can see, the car basically it's making your life a lot easier. Computers and somehow do the same. Computers makes our life easier. We use computers just like we used the car. The car was used to solve a problem, which is moving from point A to point B in a short time. Well, computers do the same. Computers can do calculations, and we can do calculations. So what's the difference between us doing calculation and a computer doing calculation? Well, a computer can do calculations a lot faster than we do. That's one of the biggest benefits of using computers. Also, we might make mistakes, but a computer will not make a mistake. Again, a computer will make a mistake if you program that computer in a wrong way. But in general, a computer will just do whatever you want it to do. So it's going to finish and do the calculations, and it's going to be done really, really fast, and there will be no mistakes. So again, this is what a computer would do. Basically, it will do a calculations a lot faster than how we can do that. So is that it? Is that why computers are invented? No, not just because they can do calculation. Well, basically, we use computers to solve problems, a lot of problems. I'll tell you something. For example, you are at home and you're bored, and you have a console, which is basically is a form of a computer. A PlayStation, for example, that is a computer system, and you have a problem, which is you are bored, and you're trying to solve that problem by going to your console, PS4 or Xbox, and solving that problem. So this is a solution here. Manufacturers, they do have a lot of those robots that do everything. Well, how are those robots are working? Basically, every single robot is connected to a computer, and that computer basically is controlling everything. So if I want to make a list of all the problems a computer can do, basically, I will be talking for hours. So computers basically help us solving problems. And we use computers because they do calculations a lot faster. Now, let's get inside a computer, and if you look inside a computer, basically you can simplify it into a CPU and a memory and an input-output device. Those are the main components of any computer system, and they are all connected using a board system, which we will call the motherboard, which is basically a set of buses that, or wires, if you will, that connect all these elements together. Now, we have the CPU and we have the memory. Those two elements are the most important two elements here, the CPU and the memory. And we have input-output devices. Now, let's say you have a computer system and you have a software in that computer system, let's say a video game or Microsoft Word or PowerPoint. That software is basically stored in your hard drive, which basically, or the solid state drive, if you have one. This software is stored in what we call an input-output device, a permanent storage device. And when you double-click on that application, a copy of that application is going to be transferred from the input-output device to the memory. And then after that, how is that going to be done? Basically, your CPU will issue a command to the input-output device, and the input-output device is going to use the data buses to transfer the data to the memory. Now, after that process is done, it's what we call the loading, and you guys should be familiar with that. After the whole program is, I'm going to try to simplify it because it's a lot more complicated than this, but just to give you an idea, that software is basically stored inside the memory. After that, the execution is going to start. The data and the instructions are going to be transferred between the CPU and the memory very, very fast and in a very, very, very fast, frequent, and that's basically how the program is going to be executed. This is not a computer hardware class, so I'm not going to get into the details of what the memory is, but just to understand this, because we're going to have a lot of chapters to talk about memories in the future. Think about a memory as a stack of memory locations, and every single memory location has a unique address, just like a building with a lot of apartments, and every single apartment have an address. So every time a CPU needs information from the memory, it's going to communicate with that memory based on the address of that memory location. Now, we're going to get into the details later about this, but for now, this is what basically you need to understand about computer systems. Now, let's move on and talk about computer software. And this is basically what this course is all about. Now, before I get into a computer software and how does it work, let's just talk about any problem in the world. How do you fix any problem in the world? Well, basically, especially if we're talking about software solutions for problems, you will have input, data that was going to be inserted into a processor. And then you will feed that processor also with instructions about how are you going to process the input data. After this operation is done, you got the input, you process the input, you're basically going to get outputs, which basically could be decisions that you're going to make, or it just basically can be results that's going to be stored somewhere. So this is, in general, how we solve problems. So we have inputs, we have a process, and we have outputs. Now, from now on, when we're going to talk about in the future, I want you to think about any problem as those three main categories or three areas. You have a problem. What are my inputs? You have to make a decision about your inputs, the data that you're going to use. After that, you're going to ask yourself, what am I going to do with the data? And then after that, what will be the results, and what am I supposed to do with the results after I get them? So this is one way to think about it. And this is, again, a simple way. In reality, it's a little bit more complicated, and we're going to get to that level later on. But just think about any software, and I'm going to go always back to the input, process, output module that I'm showing you right here in the future, so you'll understand how to write a code and how does it work. Now, back to the computer issue that we have. A computer in general, and I'm sure you heard about that before, a computer is a hardware and a software combination. Now, the hardware is something you can touch in your hand and you can see it. A software it's not. It's basically, if you want to define it as a software, it's a list of instructions that you're going to feed the computer, and the computer is going to use those instructions to get something done. Just like if you have your son and you're trying to teach him how to drive, well, basically what are you going to do? Well, I'm guessing most of you guys are too young to have sons, so I'm going to use it on myself. I have my son. I'm trying to teach him how to drive. Well, here's what I'm going to do. I'm going to sit next to him, and I'm going to feed him with instructions, and he's going to take the instructions, process them, implement them for me. So that's what a software is. It's a list of instructions. Do this, do that, jump here, jump there, fly, eat, drink, sleep. It's basically that. You're going to tell the computer exactly what to do. And that's basically what a software is. So later on, you should know that a computer by itself, even though a lot of people start thinking that this could change and we might actually see a Terminator in the future, But computers, they cannot do anything by themselves. They always need to be fed with instructions, and they will just follow the instructions as you feed them. You give them right instructions, you get right results. You give them wrong instructions, you get wrong results, and that's basically how it works. Now, programming languages. Let's jump into the real question that you should ask yourself. Why C++? Why not other programming languages? Well, I'll just advise you, go ahead and Google list of programming languages, and you'll see it's not dozens, it's hundreds of programming languages that's out there. Now the question is, out of all these 100 languages, why do we choose C++? Well, for multiple reasons. Reason number one, if you go and search for the top ranked programming language in the last 20 years, actually not 20 years, if you go 40 years, and you will always see C++ in the top 5 or 10 list. So it looks like C++ has reserved its spot as a very important programming language through the history of programming languages. Now the question is, we see a lot of programmings go up and go down and nobody remember them, but C++ has been in the area, has been around for a really long time. Why is that? Because, a very simple reason for it, because C++ talks a language that is very, very close to the processor of your computer system, which make it a lot faster and which make it a good choice for real-life applications. Now, you may ask a question, what is a real-life application? Well, let me just tell you. Embedded systems, for example, the watch that you have, the tracer for exercises, a lot of applications, they need to be really, really fast. And because of that, C++ provide a real-life processing, a real-time, processing. So that's why C++ is around for a really long time. And other programming languages are basically built from C++. And that's one of the reasons. Reason number two, we have a lot of programming languages these days are extremely easy. Let's take Python, for example, and Swift. They're really easy. They're really simple. The rules are very simple. Anyone can learn Python and Swift. Now, here's the thing. Let me just tell you this. If I teach you Python and then I will throw you at C++, you will have a nightmare. You will say, oh my God, what is this? Now, if I teach you C++ and you master C++, and after that I will tell you, well, let's learn about Python, you will feel like, oh, Python is a piece of cake. I'll get it done in no time. You see, we teach you the hard one, the tough one, so when I throw at you the easy one, you will be able to handle it with no problems. And this slide here, which basically I'm telling you, go ahead and read this link here. This is going to tell you about programming languages in 2020, and the video will show you the rank of programming languages through the history. And those two will basically give you, those two links will give you a very basic idea about programming languages and the history of programming language, so I don't have to waste your time and my time talking about them here. Now, I'm going a little bit fast here a little bit because I'm going to spend a long time when it comes to building projects and working on it. So, what is programming in general? Let's just start with that again. Well, basically, what you need to do when you want to write a code, you basically need to have a text file, and then you're going to write your instructions, a list of instructions in that text file. And then after that, that text file, you will have a software called compiler, which basically has a process or job of compiling your source file, and it's going to go through multiple stages. Basically, it's going to take it to pre-process to make sure everything's okay, and then it's going to compile it, and then the compiler is going to move it to assembler, and then from the assembler you're going to have the linker, and then you're going to have executable file, which is in C++, in Windows it's an exe file. Just to give you a very basic idea here, is the linker basically, your software is going to be connected to libraries that works with the operating system. So the linker will make sure that your software, the software that's provided by the operating system, will be connected at the linker. The assembler, well, let me just go back here. The processor itself can only run what we call a machine language. Now, machine language is basically zeros and ones, ones and zeros, which is really, really hard for people to understand. So there is a programming language called assembly, which is a very, it's an interpreted version of the machine language into an English language that we can understand. It's still very complicated. If you just Google assembly language code, you will see that something really not that easy to understand. So your code basically is going to be converted to assembly language. So after that's going to be converted to the machine language, so the processor can actually handle it and execute it. So your code basically is going to go through all these steps until it will be executable. Programming languages go through a lot of phases. We started with what we call low-level programming language like assembly, and then we got the high-level language like C and C++ and Java and Python and all these kind of programming languages. Now, this is where it gets a little bit specified. This is where you need to pay attention here. Programming and solving problems. Again, as I said at the beginning, why do we need programming? Well, basically to solve problems. Now, here's a mistake that I used to make until now. When I want to save some time, I just go and do that mistake again. If you don't want to waste your time and you want to get results and you want to have something that's very, very efficient, something that's very professional, do not make this mistake. Do not jump into writing a code. Whenever you have a problem, before you do anything, you need to think about an algorithm. So the question is, what is an algorithm? Well, have you seen cartoons when some characters, they have a problem, they don't know how to solve it, and all of a sudden that light that start lighting at the top of their head, the bulb that's going to light at the top of theirs, what is that? That basically means they found a solution. And what is a solution? Solution is basically an algorithm. And what is an algorithm? Well, if you have a solution in your mind and I ask you to represent it to me, you need to convert it from an idea in your head into a form, an algorithm. And there's multiple ways to represent an algorithm. There are basically two ways that I'm sure you heard about them before. You can graphically represent an algorithm using what we call a flowchart, which I'm going to try to avoid in this class. I think you already had an idea about what is a flowchart. And we also have what we call pseudocode. Now, pseudocode basically means you represent your idea in a form of steps in English. You just tell me, step number 1, I'll do this. Step number 2, I'll do that. Step number 3 and 4 and 5 and 6 and 7 and 8. What I want you to do in the future, whenever you have a problem and you try to solve it writing your code, before you have your idea in your head, it sounds good in your head, but before you do that, write it down in a form of algorithm and try to study it. Sometimes in your head it may look like something, and when you write it down, you might be able to see some problems with it. So the first step, whenever you have a problem you try to solve writing a code, is basically to write the algorithm in a form of an pseudocode or a flowchart. And that's the first thing you have to do. Now, in the labs, in the exercises that you're going to have in college, that's what you have to do. A lot of colleges basically they ask you to show the algorithm before you start writing code. I don't ask for that much, but it would be great if you can do that. Just think about the idea, put it down on a piece of paper in the form of steps, and then after that, think about it and ask people for their opinion. They may be able to point to some mistakes or weak points in that algorithm. So you have a problem and you try to design a program to solve that problem. Well, basically, you do have two phases you have to think about. The design phase and the implementation phase. Now, the design phase, you sit on your desk, you have a pencil, a piece of paper, and you start writing your idea, your algorithm in a form of steps. Right after that, you discuss your idea, you have a meeting with your colleagues and friends, and you guys came up with some modification, you change the design, you think this is the perfect design. After that, you go and sit in front of a computer, and you convert that algorithm or that design for the problem solving into a form of a computer program. Now, let's talk professional. How do companies work? Well, companies, they basically have what they call a software life cycle. And you work for a company and you have a client, and this client came up to you with a problem, and they said, we are hiring you to create a software to solve that problem. So here's what you have to do. First of all, you need to start with the requirement analysis. Basically, you start collecting information. You start studying the problem, trying to understand what it is. After you got everything related to that problem, all the data that you need, all the scenarios, all the cases. You move on to the design. How am I going to solve this problem? And you came up with the algorithm at the design stage. Now, after that, you move on to the implementation. You write the code. You get the code to work, and let me tell you something. You will make a lot of mistakes, and there is no company that will create a software that will work 100% with no problems at the beginning. And that's why we have the beta and the alpha versions of softwares. And you've seen that a lot. For example, companies that makes video games, before actually they publish their video game, they basically give it to some people for free to test it out. And that's where is the testing. Basically, you will have a team of testing in your company to test it and make sure everything's okay. But because of the shortness of time, you don't have that much of employee to test everything, and you want your software to have no problems at all. So what do? You give a free version of that software to people to test it. And then what they're going to do, they're going to run the code, they will test everything in that program, and they will run through a lot of problems and errors. Well, that software version of that, the testing phase, basically has one major job: is whenever there's a problem, whenever there's an error, send me a report. So a report is going to be sent to the company. Oh, this has happened, this has happened, this happened. So the company will collect all these reports and try to solve them, and then give it to more people to test it, and test it again, and keep going in the testing process until I get no more errors reports anymore. Right after that, you start the process of evaluation, documentation, and to make sure that the software is 100% correct. Now, a lot of companies, they do make softwares and they try to rush, so they don't pay attention to the testing phase, and that's where they have a lot of problems in the future. Now, the last part that I want to talk about right now is something you should understand about programming in general. C programming language is the mother of most of the common programming language that we use these days. As you can see here in the graph, from C, we got C++, we got Java, and we got Python, and we got C#, which basically, those are the programming languages that we use these days a lot. Every single one of those programming language has its own advantage and disadvantage, and I'm going to go through them right now. It's not related to C++ class or video that I'm making right now, but just to give you an idea. C++ came from C programming language, and C programming language by itself doesn't support object-oriented programming language. So C++, it's basically the same as C++ plus object-oriented programming style, which is something we're going to talk about later. Java came from a C++ background. And the benefits of Java is machine independent. Basically means with C++, if I have a software that I want to create, I need to have a version for Windows, Linux, and version for what is called Apple software, the Mac. Now, Java, basically the same software that you're going to generate will work on any machine. So that's a key feature here. That makes it a little bit better than C++, but the problem is Java is slow compared to C++. So you see here, each one of them has its own advantage, disadvantage. So depending on the application that you have, you need to make your wise decision. Now, C# is Microsoft respond to Java. And C# basically, if you study Java and then you move to C#, you will notice that you can tell without even knowing anything about C# that you know 80% of C# because they're very, very similar. C# basically only works in Windows. Oh, that's the last that I heard about. And the graphic user interface in C#, it's a lot easier compared to Java. Like you can create an application in C# in no time comparing to Java, because in C# a lot of the applications are drag and drop without the need to write a code. The Visual Studio will generate the code for you. You don't have to worry about that. You have to write some codes for the functionality of it. Now let's talk about Python here. Python is my favorite programming language so far. It's as simple as I'm thinking about teaching it to my son who is in 3rd grade right now. It's that simple. And it's not complicated, and it's fast. It has a huge library, and now these days, data visualization, data analysis, data science are using heavily Python. So that's why Python is popular programming languages. So this will be the end of this part, and now I'm going to move on and talk about Visual Studio and how to write a code, and how to compile the code, and types of errors that comes with the code. So stay there and don't leave. So let's start by asking this question. What do I need to write a C++ program? Well, it depends on what kind of machine do you have. I'm going to assume most of you guys are going to be using desktops with Windows operating system on it, but some of you might have a Mac laptop or a Mac desktop. Now, for Mac people, don't get me wrong, I really like Mac devices, but when it comes to software and writing a code, I'm not really big fan of them. So if you go to visualstudio.microsoft.com, you'll see this website. Now, don't let this get you wrong. Visual Studio for Mac. C++ is not supported here. So do not, if you're a Mac user, do not download here and waste your time. It has C#, it has a lot of other programming languages, but C++ is not included. So if you are a Windows user, this is your area to go with. Now, let's go back to the Mac people. What if I have a Mac machine? What do I do? Well, your best option is to use the Xcode. So if you just go and type Xcode, of course, you're going to have to do that using your machine. That will take you to the Apple Store, and this is the Xcode application, which basically support C++. What I would do, basically, I will go and watch a video about Xcode and C++ and how do I download it, how do I run application. In my site, I'm going to be focusing on Windows because this is basically what I have and what I'm going to be using. So in this area, Visual Studio, you need to go and you have three options here. You got Community, you have Professional, you have Enterprise. Go with Community. Community is free. Now, I already have it installed in my system, so I cannot install it again. But through the process, basically, it's not going to choose C++ to be installed by default. So it's going to show you a long list of options. What do you want to be installed in your system? Again, to save some space, don't choose everything. If you are interested in other programming languages, go ahead and do it. But if you just want to go for C++, then just look in the library, in the list of features, and just choose whatever C++ package you can see there. Now, after you install the software and download it, and you can download and install in your system, basically you'll be able to see, and you run it for the first time, you'll be able to see a window will look like that. Now, I'm not sure if you're going to have the same interface or a different interface. It could look different. Sometimes the Solution Explorer could be to the right, but that's not a big deal. Now, I want you to pay attention to how I'm going to start a new project here. You go to File. Now, this is something you're going to be doing all the time, so it's important to get it right in the first place. So you click on File, and you click on New, and you go to Projects. Depending on what you chose to download and to install, I just went with Visual Studio, so C++. So I see this list. You look for it, you don't see it, and use Visual C++ General. Choose Empty Project. You can change the name if you want. Let me just say here, for example, CS200. And you click OK. You wait a little bit. And now you can see that I got the project open. Now what you do, you go to source file here. This is very important. Excuse me. You go click on, right click on it, add, new item, and you choose C++ file. You can change the name if you want. You can keep it as it is. It's up to you. You click add. And then after that, you see this empty file here. This empty file, this is where you're going to write your code. And I'm going to go through a very simple project just to show a message. And I'm going to go through the details of that message, and I'm going to try to run it and show you how it works. So first thing, you need to start with this line, include IOStream. Of course, I misspelled it. Let me just rewrite it again. IOStream. Now, after that, I will start with a void, or let's just go integer main. I'm going to explain, of course, every single line that I wrote here. And here I'm going to type get chr, and I'm going to say return 0. And let's see, std : cout hello C++ people. And let's say here std : and a line. And I'm going to add something here, std : cout, press enter to exit. And semicolon. So here we go. This is my very, very simple C++ project. The results of this execution basically will show me a message, hello C++ people, and then after that it's going to show me press enter to exit. So let me just give it a try, and then I'm going to explain everything in this code. So you click on local. This is basically going to run the code. So you build the project and then run it. Building a project for the first time takes time, so just going to have to wait a little bit. It's showing you here the process that's going through to convert this code here from this form to an executable form. So let me just go ahead and increase the font size so you guys can see it. Hello C++ pupil. Wait, yep. Let me run it again, and here we go. Press enter to exit, and that's it. So here we go. This is the project, and these are the lines, and now I have to go through all these details to explain what's going on here and how does it work. Now, the first line that I have here is this line here, and this is extremely. You're basically going to be including this line here at your every single project you're going to create. Now, let's say, and let me just explain it here. Let's say you need to build a wall, or build a room, or build a house, build something. Now, to do that, you need tools. You can get the job done without tools, but again, if you can get the job done with tools in a month, it would take you a year to get it done without tools. So we need tools to build a project. And the tools that I'm using here is to show messages on the screen are basically going to be stored in a file. And that file, it's what we call a header file. And the header file that I'm talking about here is called IOStream, input output stream. So there is a file called iostream.h. It's a built-in file that comes with Visual Studio, so you don't have to worry about it. And think about it as a box of tools that I can use to perform input and output operations. If I want to use that box of tools, basically I need to write it in this format, include this box of tool in my project so I can use it. So that's line number 1. Now let's go into line number 3, integer main. Now, this may not be very, very easy to understand at the beginning, but we're going to talk about it a lot later. So, what do we have here? This is what we call a main function. Now, a main function in any project, in any programming language in the world, most of the programming language in the world, represent what we call the starting point of execution. What does that mean? Now, this project is very simple. It's one file, so it's not that complicated. But imagine a project that contains 100 of these files. Now, when you try to execute it, you need to give the compiler, or you need to give the operating system a starting point. Where am I supposed to start at to execute this project with all these files? Well, the main function is the starting point. So guess what? You are only allowed to have one main function in your project. Okay, now you may ask a question, well, this is the main function, so what is integer, int here? Int is a shortcut for integer. Now, what does that mean? Integer is basically a number that doesn't accept the decimal point, a whole number, like 5, 6, 0, 3, 5, 2, 10. That's an integer. It doesn't accept a decimal point. Like you cannot have an integer that is 3.7. Let me just put that on the side. Next chapter is going to be all about that. Sometimes your main function and the operating system, for example, Windows, communicate. And the integer here basically will tell Microsoft a certain type of information depending on the value that's going to be returned. So sometimes, again, we are not at that level, but sometimes when you create an application and your application after it's executed need to tell Microsoft something, so this here would define what type of information that's going to be fed back to the operating system, which basically in this case we don't care about that much. We're just going to go integer, and this is basically going to be returned 0. Give Microsoft Windows 0. Again, don't worry about that. We just put it here to avoid having what we call warnings. With something, some students, I've seen them, they get worried about warnings, but again, just to avoid having those warnings, let's just go start integer here and return. Now, with that being said, let's talk about this curly brace and this closing curly brace. This is the opening and this is the closing. This here is the body of your program, or body of the main function. This is where you write your statements. This is where you tell the computer what to do. Now, if you look here, I got 1, 2, 3, 4 statements. Each one of those lines by itself, it's called a statement. And each statement ends with a semicolon. You can see here, I got a semicolon here, semicolon here, semicolon here, a semicolon here. The semicolon basically will tell the compiler, this is the end of statement number 1, this is the end of statement number 2, this is the end of statement number 3, and this is the end of statement number 4. So the semicolon tell this is the end of the statements. Now let's talk about what does each of these statements do. Well, in this part here, this is a tool called cout. Cout is basically the tool that we're going to use to show a message on the screen. So I'm trying to show a message which is hello C++ people on the screen. So how do I show that on screen? Basically, we have a tool called cout, and that's the cout tool basically is from the IO stream here. Now, we have what we call insertion operation. And then whatever you want to show on the screen must be surrounded with double quotations. If I take this double quotations, I'm going to get errors, and we're going to talk about that later. But for now, whatever you want to show on the screen, you put it between the double quotations. Now, after that, I got another insertion operation, and I have the end line tool here. End line tool basically means instead of showing this message next to the first message, show it after it, underneath it. So that's the end line message. Now, I got another cout message here. Press enter to exit, and I decided to use this, what we call a skip character, \n. \n acts exactly as end line. Go to the next line. If I have to choose between them, I will always go with this one, because this is by itself, it's a piece of code that takes time to execute. This one is way more efficient. Now, get character. Now, what is the point of get character? Well, let me just show you that. If I comment this line, well, let me just take that out for now. I'm going to talk about comments later, but let me just delete it. And I'm going to try to run it again, and I want you to pay attention because something's going to happen really fast. You're not going to be able to see it. I hope you guys realize that. Let me run it again. So what just happened? Well, the window that showed me those two messages popped and disappeared immediately. So what do I do? Well, basically, this is what we call screen holder. I use this to keep the screen available so I can read it, and then the get character basically is waiting for you to press any key on the screen to take it. So what I just did here, I asked you to press enter specifically to move on to the next line, which is basically the return statement. Return statement here basically means this is the end of the program and I'm done. So let's run it again. And as you can see here, I can see this is basically where I'm supposed to enter. Press enter, and I am done. This project here is a very simple project. I'm not going to go in this video. I'm not going to go into the details of how to create a complicated project. I'm just going to keep it as simple as possible for now. Next video, I will talk about variables, operations, input, output operations. That one you don't want to miss because it's very, very important. But I just explained the details of how to write a code and how do you run it. Now, there are some details we can add to make the program a little bit less complicated when it comes to writing. Let me just start with this. As you can see here, whenever I wanted to use a tool from the IO stream, I had to type std : cout. I wanted to use the other tool, endline, std : endline. Now, what is that std here? Well, basically std is called namespace. Now, what is a namespace? Let's think about this. Imagine the IO stream by itself, it's a garage. It's a big garage that's full of tools. And inside this garage, we have boxes. One of the boxes is called std. Inside this box std, there's the tool cout. So because I want to use the the cout tool from the IO stream, I have to specify what box I will find the cout from. So to simplify the process, what I can do, I can come here and type this using std : cout, and then using std : endline, and that way, again, I don't need to, every time I use cout, I have to type std. So see, this way we'll simplify it a little bit to make the code a little bit easier to understand. Instead of every time you have to type cout, you have to type std : just do it one time here, and you get it done. Now the question is, what if I'm using all the tools for the input-output operations? That basically means I need to have using std : every time. For example, using std : cin, using std : string. And there's a long list of tools that I can use that are available in the std. So I may find myself writing this statement here for a lot of times. Now, is there any way I can simplify it to myself? Well, there is a way to do that. And what I'm going to do here, I'm going to show you that. I'm going to keep those for now, but you have this option, using namespace std, semicolon. That basically means I don't have to list all of them. I can just do it one time and I'm done. So I don't have to have those here anymore. Now the question is, which one of them I should go with? Well, this here is for simplicity, but in reality we don't do it that way. And let me just show you why we don't do it. We actually go using std : cout. Me and my using. Using std : endline. And I am going to take this away. Now, before I take it away, let me just explain why it's more efficient to use this one. Now, I want you to think about this. You have a project in your garage, in your let's say front yard, and you have all your tools, all your boxes inside the garage. Now, would it be easier for you to only go and get the tools that you want from the box to your front yard, or it would be easier that to get the whole box every time you need to use one tool inside that box? Of course, getting the tool, open the box in the garage, get the tool and use it, and instead of carrying the whole box. When you will carry the whole box, if I'm going to use all the tools in the box, then yes, it makes more sense to carry the whole box and get it out. But if I'm just going to use one or two of the 100 of tools inside that box, well, there's no point for me to carry the whole box into to my front yard. Same thing here. When you type using namespace, you're basically loading the whole namespace, all the tools into your program here. And yet, let's imagine there's like 100 of them. How many of them I'm using? I'm using just 2. So it's basically loading 100 tools that I'm not going to use when I only need 2. So instead of doing this operation, basically, I'm just going to load the tools that I need, which is in this case, cout and endline. So this is basically going to make your code a lot more efficient. Now you may ask about what is this place here? What is this screen holder here? This is what we call a command. Now, what is a command? Not a command, sorry, a comment. A comment is basically a line, and as you can see, it's green, that's going to be shown on, it's not going to be shown basically, you're going to type it in your source code, but it's going to be ignored by the compiler. So when I run it, basically the compiler will ignore whatever it's here. So why do I need it? Well, exactly, just like you see here. I put screen holder to explain to you that get character is just to hold a screen. So this here, me explaining what is this statement, this is why we need comments. So in the future, I need you to write comments a lot. This is a way that you can actually tell people that you are a good programmer. So I'm just going to come here and add more comments. Okay, so this is different. This is for a single line comment. This is for multiple line comments. Name Adam Ross. Date, it's 6/4/2020. Time 11:50 a.m., which remind me that it's almost time for lunch. What is this? Demo. C++. See, this here, it's me documenting my work. Here, this is me writing, explaining a portion of the code. And those are the main 2 reasons why we need to use comments here, to explain or to document. Now, one part is very, very important also about code. Let's just imagine. Now, I want you to think about a project that contains, let's say, 200 lines of code of those. 200. You write your code and you try to run it, and it's not working. It's not giving you the right answers or the correct results. And then you realize, oh my God, I made a mistake here. This was not supposed to be hello C++ people. This was supposed to be hello, for example, C++. Wait a minute, let me just put it back. Oops. This wasn't supposed to be hello C++ people. It was supposed to be hello C++ students. Now, I have 2 options here. I can delete this and keep this one, or I can convert this to a comment. Which one of them you would choose? I'll count to 5, and you make a decision. I'm going to answer that question. 1, 2, 3, 4, 5. Okay. So I will go with converting it into a comment instead of deleting it. The answer for your question, which is why would you do that? What if after, let's imagine, this is not a single line, let's just, there are 25 lines, and it happens to me before, by the way. You find a mistake, you delete it, and you start writing a code again, and then you realize whatever you did before wasn't a mistake, what you're trying to do now is a mistake. All you have to do is just update it and change it. So If you choose to delete your code, that basically means if you want to go back to it, you have to rewrite it. But if you convert it to a comment and you decide to go back to it, well, guess what? It's there. It's going to be ignored by the compiler, but you're still going to be able to use it. So I realized, well, I know it's a student, so I don't need to write a new code for a student. I just have to come here and change that to be students. Okay, now the question is, what if I have a lot of those comments? What do? Do I keep them forever in my code? Well, here's what you do. For the documentation part, you keep it. For the explanation part, you keep it. After you comment some section of your code and you wasn't sure about if it's right or wrong, after a period of time, after you get the final version of your code, and you realize that, yeah, that was a mistake, then you can delete it for sure. The last part I want to talk about is errors here. Now, when you write a code, it doesn't matter what kind of programming language, we have 3 different types of errors. And I want you to pay attention to this. We have what we call syntax error, runtime error, and logic error. Now, let me show you what is a syntax error. I am going to take this C away and convert it to an uppercase C. Syntax errors is the easiest errors. The moment you have it, this wavy red line is going to show up, and if you put a mouse here, it's going to tell you, I have no idea what is an uppercase C out. And of course, if you have some experience, you will realize it has to be a lowercase. Now, let's imagine that you decided, I'm going to run it anyway, I don't care. Immediately it's going to tell you, oh, do you want to run it? Say no. And it's going to tell you here the same error again. That's a problem. The good news here is going to tell you, it should tell you, well, here it is. This is line number 13. That's where you have the error. Double click on it and you'll see an error pointing at it. This is what we call syntax errors. Syntax errors are the easiest ones, my favorite one. You will learn a lot from syntax errors. That's error number 1. Error number 2, logic errors. Now, not logical. Let's just start with runtime errors. And I'm going to show you an example here. C out. And I'm going to talk about this later tomorrow, next class, sorry, next video. End line, some I call. Now, do you see any wavy lines here? No, I don't see any wavy lines. Well, actually, let me just fix this first. Okay, no wavy lines, so there's no syntax errors. Let me try to run it then. And look at this, another error. And here it is, divided or may mod by 0. So you are trying to do something illegal. Let me put 2 here. You see I got 5. It's working. But if I try to divide by 0, the compiler will not accept that, and it will throw an error for you. So this is what we call a runtime error. Now, I want you to imagine that I asked the user to decide what is this value supposed to be. Instead of 0, for example, tell me 5, tell me 6. Depends on where am I getting this value from. So this runtime error basically is an error that could happen while the program is executing. Even though it didn't happen now, but it could happen when the program is executed. So that's the runtime error. I'm going to show you that more example about that later. Now, logic error, that's the biggest problem. Because let's just imagine here. I typed this. Let me run it. No syntax error, no run error, but what is this? That's what we call a logic error. Logic error basically means your program is working, there is no mistakes, there is no reasons for the program to crash down, and yet it's giving me results that doesn't make any sense. And that's a logic error. Logic error basically means your whole idea is wrong. That could be one reason, which is basically something you wish you don't have. Or it could be that in the middle of the processing, you mistakenly, instead of adding 2 numbers, you subtracted numbers. So of course the results are not going to be correct. So logic error basically means it might be a reason, the logic error, for a problem with the whole idea. Or it could be that one of the operations that you did wasn't supposed to be in that place, as I said. Instead of adding, you're subtracting. Now, why am I saying logic errors are the worst? Because with syntax errors, let me just show you. Here, it's telling you go to line number 14, even though it's not 14, it's basically 13, which is missing the semicolon, but somehow the compiler will tell you where's the problem. Logic, runtime error, same thing. The compiler will tell you where is the problem. But logic error, no, there's no problem, there's no errors. So you have to go through all your code, which could be millions of lines of code, trying to figure out where is the problem. And that's why logic errors are the worst. This will be the end of this video. In the next video, I'm going to talk about variables, operations, selection statements, and repeating statements. So thank you for watching, and I'll see you guys soon. Bye.